Today, I'm going to discuss on one of the basic concept in the Java knowledge, object serialization. So we are going to talk detail what is this and how, what are the theory behind that, and generally this terminology, Java object serializations, we talk whenever we are communicating between the services. Let us we have a service A and another service B. Okay, they want to send some message, some data to A. So generally, if this application written in a Java, okay, generally we have a Java object. So is it this Java object we can directly pass to the B object? So what are the way? Because this is the application running in the specific JVM, okay, JVM1. This application might be running in the JVM2, JVM2. So this object, generally, whenever in our Java application you create any objects, that's created inside the JVM, Java Virtual Machine heap memory. So this object, this memory, whatever the this JVM, this JVM cannot access because this JVM, maybe this is the particular specific IP address this machine. This application may be specific particular IP address. So question is that if the particular object created by the JVM1, can this object similar object access here or not? So such a scenario, the Java use the concept of object serializations. Whenever they are sending a object from machine one to another machine, they are not sending direct Java object, or just write in a string representation text format. Okay, so we have an option, we can just make a one text format and send here. Okay, so once this object, this service receive the text representation of your Java object, it is very hard for that they convert to the again Java object here. So the purpose here, application one have a Java object. They want to send to another application that is also Java's application. So why not they can get the Java object without any kind of extra work required to do the service B. So such kind of a data exchange, object exchange between the service one, service two, module one, module two, even within a JVM. So lots of theory related to the Java serializations we have. So let us talk more detail about what is the Java serializations and the theory concept, and I'll try to write some code as well as so that you can understand how the serializations and corresponding one other concept is the deserializations. So once service A want to send service B, so whatever the Java object have a, they make a serialize the stream of byte, and this stream of byte slowly reach the here. Now this stream of byte can again convert it to the same Java object in a string B. This is the serialization and deserialization process. So let's talk a little bit more. So as we talk about the serializations, so as I already mentioned, serialization is the process of converting Java object into the byte stream. So simple, serialization is a process of converting Java object into the byte stream. What do you mean by byte stream here? Maybe any object. Java is the object. So this object have a some information. That's an employee object. The employee one have a state like employee name, age, his address, right? So whatever the name, whatever the age, whatever the address, these are the information. So these information can be in the form of text, So what do you mean by byte string? Byte string is also information. Generally, whenever you are sending content on the network, generally always traverse in the form of string representation. So this is a string, but this string not the flat string that holding the name, age, address. Apart from that, they also hold the structure of the employee class. That means what is the class name, what are the attribute name, what are the data type, what are the access modifier, everything they can maintain. So that while the deserialization process, JVM can very easily again convert to the Java object. Objective of this serializations is that whatever the data we are sending from service A to service B can very easily again convert Java object. So generally, these serializations you saw in this following section. Maybe sometime you want to save your object state, whatever the your object, okay, whatever the object state you have, maybe multiple object state you have, you want to save in a particular file, maybe some particular file system, okay, and later part you want, hey, already I have a save information, can you again make the same object which are previously look like Java object? So this is the serialization process and this is the deserialization process. The one format, one use cases of the serialization, sometime you want your Java object state. So you have three terminology. In a Java, one is the class. You write like employee the one class. Employee class. What is the class? Class is just blueprint or the statement tell about what the information you are going to the capture for employee. Maybe employee name, employee age, employee ID. So this is the class. So once you have defined the structure of an employee, for every employee you are considering employee ID, name, age, address, everything. So now according to this class, you can create the instances. That means employee one, maybe employee two, maybe employee three, right? The multiple employee, each employee have a different name, different ID, different address, right now. So these information, whenever we talk about the serializations, the instance, that means the state of an employee you are going to see. So that time serialization process, what they are going to write everything in the form of string. They are write the your class structure, class name, property, field, data type, everything, so that once the deserialization process happen, JVM know everything, right? So one use case for the serialization is you have to write your object state, Java object state in the file. Maybe sometime you want to send over the network. That means in the microservice environment or the distributed application environment, maybe your server deployed to the one part, another server deployed to the another part, and you want to exchange data between these. So those scenario, maybe you talk about the RMI call, socket programming, or REST API call, WebSocket call, all kind of network communications. Those scenario also, Java application want to send data, then they are going to take the part of the object serialization. Sometime you want to store these object in the database. So while storing in the database, also we need the serialization process. So the use case is multiple. I'm not going to talk everything, but whenever you are working in applications, you can visualize these are the scenario where our Java applications going to store the object states in the proper format so that the later part, oh, the byte stream can later be deserialized to create the Java object again. So whole the purpose of the serialization is that we can convert this is my Java object. This is my Java object can convert to the specific format byte string so that later part again we can convert the Java object. So while the again deserialize, this is the serialization process, this is the deserialization process. So while serialization process, JVM are going to put all those required information that required while the deserialization process. So while deserialization process, they need a class name, they need a field, access modifier, everything, so that they can construct the object. So whatever the serialization is the process to converting Java object to the byte stream, and byte stream can later be deserialized to create again the Java object. So this is the concept of the serializations and deserialization. So again, similarly, sometimes someone talk about the deserialization. Deserialization is just the reverse process of your serialization, converting byte stream back to your Java object. That means first, this is the stream of byte stream of data. So first we have a Java object, using the serialization process, you can convert it to the byte stream, and later part again read and again convert to the Java object in the, maybe this is in the JVM1, this is maybe in the JVM2, are different machine. So this is the byte stream, this is the Java object, this is also Java object. While converting Java object to the byte stream is the serialization, and again from byte stream to again convert the Java object, it is the deserialization process. Okay, so let's do some more use cases about the serializations. So serializations are useful couple of scenario. I'm not going to talk everything, but couple of. So first thing I mentioned, whenever you want to persist the object state, be careful. We are talking about the object state. State means, for example, employee 1, employee 2, employee 3. Each employee have a unique employee ID, employee name, address, debit. So all are these value consider the state of employee. Similarly, employee 2 also have a name, age, address, field. These value are the employee 2 state. Similarly, employee 3 have a different state. So these are the state. Whenever you want to store the employee state, the object state, that time this is the use. Sometime you want to transfer object between JVM. That means ki different application 1 and application 2 want to send, I exchange the object basically in the distributed environment, maybe microservice environment and distributed environment. Distributed environment, that means your application is not deployed in the only one machine. Maybe they are deployed in the different machine, different network. So here in the distributed environment, sometime you want your data, your Java object can be can be transferred from one JVM, one application to another application, another application to another application. So this scenario also we are using the serialization process. And one of the most common use case also about the caching object. Sometimes you want to cache for temporarily store the object, and later part we can deserialize, or maybe send over the network. Maybe you are going to the call microservice call, REST API call, HTTP call, socket call, WebSocket call, HTTP WebSocket call. Lots of communication nowadays. Lots of technology available where service one, microservice 2 can exchange data between this different protocols. So while you are using any protocol, maybe you are using Kafka protocol, TCP protocol, IP protocol, any UDP protocol, whatever the communication channel you are using, you need to send the object. So while sending object, you need to serialize. So serialization is the kind of concept that every programming language, every application support, so that they his applications are able to exchange messages from one application to another applications. So next step, how it's happened, how Java help to do to object serialization. So let's think how it works. Okay, the theoretical part's good. So Java, whenever let's you have a one Java object, Java object you have, the Java object have. So how this object are going to make a stream of byte, a stream of byte, and again back converted to the Java object. Okay. So for that internally, uh, Java have a given some interfaces and some classes. So two more interface generally while object serialization and deserialization we have two use. Okay, one is your object output stream and one is the object input stream. These are the two major are very important classes in the serialization process. And one whatever the object, employee object, user object, person object, whatever the object you want to going to serialize, how JVM know hey this object can be serialized or cannot serialize. So for that Java provided one marker interface known as a serializable interface. So serializable interface, just a simple interface, and that interface does not have any predefined abstract method that your class is going to override or implement. So in a Java, generally, whenever you define an interface, in interface, generally you are defining some kind of a abstract method so that your implementation classes can go and must be implement those methods. But in the case of serializable interface, there is no such a restriction. That means Java community given this serializable interface just for identification that this object, employee object, user object, student object are going to serialize. This is known as a marker interface. Just yeah, identification interface. Okay, so here one interface that means ki whatever the class, maybe your class, you have to implement your serializable interface. This is the marker interface. Marker interface that means there is a no any abstract method specified here. That means you do not need to override any methods. They are not enforcing. Just implement serializable interface. Now at least JVM know this object is the part of serializer. By default, Java support serializer. Even you do not mark anything, just mention your class implement this serializable interface. Rest everything is taken care by Java virtual machine, JVM. But question is that then why these two classes? Sometime you want to write a particular file or send to something, that time this help us to write data in a particular file, write the object state in a file, and this input stream help read from the file. So whenever you are going to store object state in the file or somewhere you want to send, that time this object output stream and input stream, two classes, this is object output stream for serialization and object input stream for the deserialization. So these are the inbuilt classes provided by the JVM for us. So in the whole today's session, mostly we are going to talk this object input stream and object output stream and object input stream for the serialization and deserialization. And must the object which you are going to serialize must implement this serializable interface. These are the very basics. And something you, before we are going to talk, you have to understand some primitives of the Java serialization working. First, we know is the marker interface. That means serializable interface is a marker interface that have a no any abstract method. Just this interface tells JVM that object can be serialized or not. And one of the whenever you are going to write your class implement serializable, some things you have to remember. Okay, whenever your object going to serialize and while deserialize, the structure of class should be the same. So how JVM know? So for those scenario, there is a concept like a serial version UID. The unique UID used during the serialization to verify the sender and receiver of the serialization object are compatible. Because right now, this is the object and you are here deserialization. The while serializations, the way you serialize, the way you are deserialized. If both environment, your classes are not structured, not compatible, then the serialization may be failed. For ensure that you make both places while object serialization and deserialization, use your class should be compatible. So this help us. And one things, be aware whenever you are going to serialize with object have a state have a different Java have a different types of field, maybe integer field, float field, static field, non-static field, volatile field, transient field, lots of things. So question all the fields which are in your class is the part of serializable or not. So by default rules of Java serialization is that all the non-static field and non-transient field are considered as a serialization of serializable fields. So if any transient field are marked as a not serializable. What do you mean by not serializable? That means let's say a class have a object have a field one, field two, field three, field four. So whenever you are going to serialize them, yeah, every four value we are going to write or something skip. Yeah, we by default Java going to take all the non-static field and non-transient field as a part of the serialization. Rest everything like static field, transient field, these are the not going to take part while the serialization and deserialization process. Okay, and one thing in the Java support kind of a relationship object 1 maybe have relationship object 2, maybe object 2 have relationship object 3. So while the serialization such a relationship maybe composition or inheritance, Java serialization can obtain the graph and try to make feasible. If an object contains the reference of another object, then it also be part of the serialization, because whenever this object contains another object, they are going to also become a serializer. They are also going to serialize. Depend upon this is the mark as a serializable interface, this is marked as a serializable interface or not. If these are not marked as a serializable interface, they are skipped. They are marked as a serializable interface, then it will take as a part of serialize. So these are the theory part. So let's go with the simple. Let us you have one simple class. So how we can say, hey, this class is serializable or not? So simple. Let us take one class. Okay. So one thing, let's we create one class and just implement the serializable interface. This serializable interface come as a part of java.io.serializable interface. And if you uh, right click and go to implementation, you notice uh, go to type declaration. Okay, here. So if you go to the documentation, notice this is a just public interface serializable, and in this interface there is no any variable, no any method, nothing. And well documentation here, just go and read out. This is notice this, the interface is just one liner, and the documentation is so high. Notice the huge number of size of document here written. Because while Java objects relation, lots of things happen internally. Okay, so for the good part, whatever I am going to talk or discuss here, that everything come from this Java object serialization specification. The Java have been given well documentation about this, how complete serialization deserialization happen. So this is the well. I'll share this link in our references so that whatever the things I'm talking, everything that come from, just let's just copy this here and just Google here. Okay, and then you will get the complete specification. Okay, you can find out. Okay, so whatever the things I'm talking that's come from this Java object serialization specification. Okay, great. So let's go. So notice these are the just marker interface. That means an interface that does not have any method, any abstract method. This is come under the Java marker interface. So let us we have simple one class, user class. Okay. Okay, let me we have a duplicate. Somehow. Let's me yes. Move to here. I have to just here just this. Just delete. So I have just deleted them. So we have a simple one class. Class name is a user, and user have a name, age, and pass. So notice I have mentioned these are the simple string variable, integer variable, and I mentioned is a transient. So I mentioned that while object serialization, the transient variable cannot be serialized. This is a default behavior, but sometime you want to talk detail, I will do. But simple notice we have a simple. This is the class. This is a simple class. This is a simple class. But you want this object can be serialized, can be deserialized. Then you have to implement your class as a implement your serializable interface. This is the only interface you are not going to implement any method. Just mention this is it. Now this your user object is eligible for the serialization. Here I mention the serial version UI. Okay, so good option as for the practice. Whenever you are go mention this serial version UID, you mention this is the annotation that serial. That means JVM or any documentation. No, this field is specific for the Java serialization and deserialization. There is no specific role for your user's object. Okay, so that is the one Java documentation yeah, annotation we can use. So good. Now let us create the Java object and try to serialize the object. Okay. Okay, so maybe some issue. So now let's think how we can serialize the object. So very simple. Serializing object is a very simple. Let's go to the main method, and you just create one user object with the name John age 30, and you can use this implement implement implement. Okay. So these all are the package come from java.io dot file output stream, file input stream, or serial annotation, etc. Everything come from there. So what we did here, let's me this API expose the exception. You can just throw exception. Okay. So here is the very simple. You have a one user object. Okay, and if you print here as out users. So if you print here, the user print there. And now what you say? I simply say, hey, I am going to create the object of object output string. Why I want to serialize my this user object? Java is the user object. I want to serialize. That means you are going to writing the byte string in the particular file. So you mention, hey, this is a file user.ser, any file name, and just say object output stream. This is the output stream dot write object. The write object is the method that's convert our Java user object to the byte stream and write in this file. So till now, what we understand, uh, we have a one object, user object, right now. Now I have want to create one file one file. Okay, and I'm going to say, hey, Java object output stream, go and write object. So they are going to using this object output stream, they read here and write in this file. So simply Java object output stream is a class. You can create the object class. While creating object, you can pass the file name where you want to store the byte stream data. This is mentioned the file output stream, and just say, hey, object dot write object. Now just mention the serialization tab. So very simple. Object output stream have a method write object. They are by default going to serialize, right? And let's run and test. So if you run, then here you notice one file. Maybe user serialization can be created. So let's run this file. Notice this is the file one created user src, and notice here before serialization I have written my user object. This is my user object which are I am written. So notice here I have a name, age, and password also showing. Okay. These are the serialized, but this is the object, Java object. There is no any concept serialization. So once they are going to write the serialize, at that time we are written it. So let's read. This process known as a Java serialization. Writing your user object via object input stream using the method writeObject. So let's think how to deserialize. This is the process known as a serialize the Java object. Just you use the object output stream, write user and write the value. And let's read how you can read them. So I just commented out these are them commented out. Okay. Now we are going to read user from this file. So I'm saying, hey, here I'm going to say object input stream. Hey, file input stream, go use this file and read object. Read object here the deserialize. Write object is the serialization process. Read object the deserialization process. And give me the user. This is the deserialization. So if you be carefully read this, let's open in the Finder, and you can open this in maybe text editor. So notice this is the file that is nothing more written something right now. If you notice here, so here something notice here written some package name, some age, some field, but notice they have a lots of junk character because this is the not plain text so that anyone can understand. This file is understand by the JVM. JVM know how this object is serialized, right? So let us tell, now we are going to tell JVM, this is my user serialized file. Can you just read using the object input stream? They have a method readObject, and they can read and give you the complete Java object. There is no thing you have to do. Just run it and notice here you found deserialized object username, and notice the password is the null. Password is the null. While because our class say this is the transient field. If it is a transient field, that means they are going to not make a part of the serialize. If you remove it, if you remove here, just remove it. Remove here, and here just again say hey, uncomment, write and read again. Now notice they are same username again come here. So default rule is that please ensure that the particular field you want cannot be the part of serialization process. You make as a transient or you can make as a static. So only non-static and non-transient variable is going to take as a part of serialization process. So very simple things till now we understand. You have a Java object, you want to serialize them. You have a Java user object, you have Java user app, you want to serialize them. Then you have say use the object output stream. Write object is a method that can take user and serialize into the file name as a user.serializable. They are written in this file. So this is known as a Java serialization. Deserialization from this file, I am going to read using the object input stream and say read object. So here the object input stream read and convert into Java object. So now again this is the deserialized Java object. So this is the Java object. You are converting to the byte stream, the serialization from byte stream converting to the Java object, the deserialization. So this is a very simple serialization and deserialization concept, right? So let's talk about custom serializations. What is the custom serialization? That means you want to control how the object serialized and deserialized rather than just rely on the default. So this is the default behavior. Default behavior is that any Java object can have a all the non-static field and non-transient field are going to take the part of as a serialized. But sometimes you want to control which field I want to serialize, make a part of the serialization, which field cannot be make the part of serialization. That means I want to know a specific field would be the part, a specific field would not be the part. That means you are going to customize the default behavior of Java serialization. So whatever the default behavior of Java serialization, it's good for all the general cases. But sometime you want something my own behavior. That means you want to change the default Java serialization behavior. Is it possible? Yes. we can do. The question is that why we need to do change the default behavior of Java serialization process. These are some use cases. Okay, these are some use cases. Okay, maybe notice here you want to encrypt or compress data before serialization. So whatever your Java object state have some value, before going to serialize, you want to apply, this is the field, I want to apply some encryption or some decryption, or I want to just, this is the huge data, I want to compress them. Okay. So before serialization, you want to do something, or you want skip or transform a specific field. So let's keep this is the field specifically I want to skip this. Or you want to some backward compatibility with the older version of serialization. Some have a older version of serialized object. Now your newer version of application, you want to load those serialized object. So those in such a scenario, you have to go and override the default Java serializable behavior. Else your serialization process will break. Okay, so Java allow us to override or take our own control while the Java serialization process. Okay, so for this, what we have to do, how to achieve? So for that, we have to override two methods for the serialization process. So notice in the serializable interface, there is a no any abstract method that you need to override. But you want to overwrite the default Java serialization behavior. Then Java object serialization specification tell us, hey, you go and override these two methods for the Java serialization process and this for the Java deserialization process. If in your class you are going to override these two methods and give your own definition, whatever you want, JVM call your method. So these two methods, if you just written these two methods in your serializable class, and that this method automatically call during the serialization and deserialization process. So whenever JVM know this is your class, this is the implemented serializable interface, that means this will going to take a part of serialization. So while the serialization, they are going to go call your method. That means overridden method. That means now the developer have a full control what things they want to do while the serializations, and they want what they want to do while the deserializations. Okay, so let's think. Let's do the practice. So I'm just create one simple class, one more simple class. Okay, I have just create one employee class. So employee class have a name, age, and a transient field password. Okay, similar, good. So here by default I implement the serializable interface. Okay, okay, good. So default behavior we know they are not going to write something, but I want my password field go with some encrypted form, because while deserialization I want to some specific password but not go as a part of, so something encryption decryption you want. So for that what we can do, so what, okay, so here one, so what we have to do, we have to go and override these two methods. First method we have to go override this for the serialization process, right now. So for serialization process I am going to write override method. What is this? Object write, and here again object output stream. So we have a method like here default object. The by default, I want to inherit all the default behavior of the Java serialization process. But I want to, for password field, I want to encrypt the password and then write in the object. So here I simply apply some encryption algorithm for the specific field. That means while the default serialization, you are going to take the default serialization process, but apart from that, you are changing our password field also be serialized. Because by default, this is a transient field. That means they are not taking the part. But you want no, I want to password field should be the part, but with the encrypted value, with a change form. So this is the methods automatically invoke while the serialization process. Similarly, for the deserialization process, you have to again write the read. Okay, okay, you have to note it. So while the deserialization process again say, hey, I am going to use the default deserialization process, but I know I already added one password field as a default, not default, as a write object, custom write object. Then I go to read object and convert my password. Again, here apply my decryption algorithm, decrypt the password and set the id. So here you are able to encrypt and decrypt. Means while the deserialization process, you are going to encrypt your password field. While the deserialization, you are going to encrypt your password. Sorry, here while the writing object and the deserialization process, you are encrypting your password. While the deserialization, you are going to decrypting your password. Okay, so let's look the how to test. So here I am going to just comment out. Okay, just I am comment out everything. Okay, so let's here go and write. So what we are going to do? I am going to create one employee with the name and password, and I say, hey, just go. Again, it is the same object input stream serialization process. So whenever I am going to write object at this time, because already in my employee class, employee and level, we already written this write object method. Write object method. So this method was invoked. If you want to verify, just say out invoke, or maybe here you want to say out. Okay. So once this mask was going to encrypt, they are going to write. If you run here, notice the employee object is the serialized, but before serialization, notice before writing this message, they also say custom serialization password encrypted. That means this write object method, object output stream, write object method are internally known. They know okay, hey, this is the employee object. Employee object already have overridden this write object method. Then this method they are invoked. So they are using the default behavior plus our own behavior. So let's now notice this is the file employee serializable file is something done. Now let's comment and to deserialize this. So let's deserialize this. Okay. I say, hey, let's read this serialize employee serializable file, and using the on object input stream, just say a read object. So I'm going to call the this file read object, and let's we are able to read deserialized employee class or not. Notice this serialized object have a my password. Notice default behavior is that transient variable cannot be part of serialized. But you say no, I want to override the default serialization and deserialization process. Now I can write my password field. So while the serialization, you have a written encrypted password, while deserialization, you again decrypted the custom password, and you can get the complete the transient variable as well as. So here in the custom object serialization process, now you have a full control what the things you want to take as a part of serialization and what the things you want to take as a part of deserialization, right? Now this is very handy way JVM providers developer can customize the default behavior of Java serialization and deserialization. So I'm going to talk to more special methods. One is the writeReplace and writeResolves. So these are the, if you read the Java object specification, they are talking here about that. If you read here, they are talking about these methods. Okay, so I'm going to talk. We'll read here. Okay, so these are the two special methods. So question is that why I'm talking? They have some scenario. Okay, what the scenario? So let us this writeReplace method is called before serialization. So before serialization process start, you want to perform some additional activities. Then you have to override this writeReplace method and do something. And allow you to replace the object being serialized with another object even you want. So sometime you want to implement maybe proxy design pattern, singleton design pattern, or you want to some version compatibility pass. So in this scenario, we have to override writeReplace method. Similarly, one readResolve also a special callback function. What this is called before the deserialization. While the deserialization, same come replace the deserialized object to another. We have an option. While the deserialization, any object you can replace. And even sometime you want to preserve the singleton or ensure the object identity. You want in a particular one JVM only one object can be as a singleton. So they are going to ensure your singleton object should be singleton. Preserve the single instances. Whatever you want before the deserialization, don't want a new object can be created. Already we have just written the same one, right now. So these two special method writeReplace is invoked automatically before the serialization process, and the readResolve methods is invoked before the deserialization process. Okay, so let's understand the basic theory about this writeReplace method. So this method help to do couple of things. One is maintain the singleton behavior. Singleton is one of design pattern which help us to whenever you are going to the create a Java object. This is the class. This is the class, and in this class you can create object one. You can create object many number of objects you can create. But this design pattern help us say I want only one object created for the particular one class. This is the one class. I want only one object can be created in JVM. No two or three objects can allow. So this is known as singleton. So sometimes you want to implement the custom logic for the object substitution, or maybe you want to avoid duplicate instance right now during the deserialization process. So this scenario, you can use this replace your write method. So let us one example. I'm going to implement one singleton. So here my objective is not to make how to understand the singleton design pattern. This is a very simple. The singleton design pattern is just a concept where you ensure that one JVM only one object can be created for the given class. Like this is the class one. So basic and simple way to implement your singleton is just make one private, static, and final field, and just initialize with the object which you want, and ensure that the constructor would be make a private so that the new object can be not created. If someone want to create more object, just call the get instance method, and whatever the object you created, just return. And here you want to ensure that during the deserialization, this method could be invoked. Okay, call. So if you are going to serialize and deserialize this singleton object, at that time you want to ensure that they are not going to, because this is they are not going to create new object. They are just return the same instance which already the JVM had. Right? So they are going to ensure that always while serialization and deserialization, even your singleton can preserve. So let's test. So let's comment out the previous one. So here I am create one singleton instance. Now I'm going to serialize it. The by default the behavior is that this is the always only one object. Let's if you print here s out in singleton instance, and let's and again you can create instance 1, and let's create instance 2. Instance 2. So both is the same instance. They are not, because here main server will call this, and if you are trying to create the instance using this using the like this way, new, and this way, they are not allowed because you mention your singleton constructor is the private is not allowed to create the object, right? This is the not way possible. You cannot create the object. The question is that how we can create the object. Then we can expose one static method. Static method can be invoked from your class name. So from class name I can invoke, and within a class, private constructor can be accessed. So within a class we create one instance variable, and here I can say new singleton. So this is the static and final. The only one instance is created at the in the get instance method. You return the instance. Okay, so that is the part. So let's just serialize, and notice that whenever serialize and whenever deserialization happen, at that time you also want the same behavior would be preserved. Those scenario we return this read resolve the method that help us. Okay, and let's run it. So here when the notice the objects both are the same object. Notice the both the same object, and one this is the object created somehow. Somehow singleton object is created for us. So let's deserialize and check again. My same instance will be preserved as a, notice that this is my hash code for the. So let's I comment out and go make a deserialize. Deserialize. So again, deserialization, we have to object input stream. We have to just read the object. Okay, we have to read the object, and this is the instance 1, and this is the our again. Let's create another instance and check the deserialized and original instance. These are the both are the same, are the different. Notice both are the same. Both are the same object. Both are the same hash code. Notice same hash code. So here we are ensuring that even you notice while the deserialization, notice our resolve method call, and they are going to ensuring that you always return the one instance that you have already won. So this read resolve help us to maintain our single instances, right? So let us talk about the a write replace method where you are going to use the write replace. But sometime you want to serialize a proxy. Proxy, that means ki, same object but not original. Can I just fake that means work on the behalf of another. Let's see, I am a original and some work is responsibility. I am teaching, so this is my responsibility. For some time, let's say I keep another teacher the same course they are going to someone teach. So this is the proxy of me. I am not teaching, but you think, hey, the same teacher is teach by us something. The proxy means roles and responsibility are taken care by another object, but the same roles and responsibility. Okay, so let us understand this. Just we have a original object we created. We created one object as the person is the one object right now. And let's for a person, I can create one more proxy person kind of object right now. So let's create one more object proxy person. So I created one more object is the proxy person. Okay. So added here annotation. This annotation just tell us JVM, hey, this is the. So what here we have a one class person. Person have a name and his constructor, and is the methods like our write replace. So whenever you are going to serialize the person object, at that time you say I'm not going to write the person object. I am going to write the proxy. So whatever the name I have, I can create my proxy and write them. And whenever someone going to deserialize, so whenever someone going to deserialize, so while resolve read, here say, hey, now at this time I'm going to return the original person. This is the way proxy class work behave like a original class. So let us serialize object. So I am going to just comment out this and serialize the object. Okay. So I created one person object. I created one person object and object output stream right. So now I am just going to serialize the person object. And while the write object, notice the person class we have written in the mention in the person class. In person class we mention write replace method. So while serialization process, this method before invoke right now. So let us check they are invoked or not. This is the serialization process start because why? Because the person class is implemented as IO serializable. Okay, and just run. So notice these are invoked before serialization process. Similarly, so now notice while the serializations of person, I have say, hey, go and serialize the proxy one, not the original one. So our file, the person files here created, they are proxy something going to store. But while deserialization, because here I am working on not the I'm here working on a person, and I want to deserialize always on to get the again person object, not the proc. But I don't want to preserve the person actual in the deserialization process. So let us go to the deserialization process. So let us comment out this person. Okay. And let's read from this person deserialization. So I am reading from deserialization. Notice after deserialization, I am again getting the person object. I'm not getting the proxy person. Notice this person dot serialization object contains something proxy object on the behalf of person. But whenever they are going to deserialize, while the read object method deserialization start. The before deserialization going to start, because here our JVM know this is the proxy. The before going to deserialization process, they are going to call the read resolve. And here I can say, hey, I am proxy, I am going to make actual the person object. So if you not run here, you are getting the actual person object. Notice that this serialization is the actual person object you can deserialize. So while serialization, deserialization, sometime you want to ensure before and after customize your behavior you want. That time you have to say read resolve and the writeReplace method help us to solve the purpose. Okay, so these are the some point related to the serialization process. But Java have also added one more interface known as a externalizable interface. So Java say कि you can do Java serialization process from the two interface. One is the serializable interface which we talked. Next about this externalizable interface. Question is why? Notice till now whatever the serialization process we are got the control default Java serialization process. But here they mention serializable interface is the interface that extend the serializable interface. The externalizer is just a sub interface, and they give us the complete control over the serialization and deserialization process. Even I want to fully control, not the specific in the course. Notice in the last session we are at least use the default behavior. In this case, our custom employee writer here is in the default serializable plus my additional encryption and decryption. But now I want to control full control over the serialization and deserialization process. So Java recommendation, if you want completely full control of your serialization and deserialization process, then you can use the externalizable interface, and that is your responsibility whatever you want to do while the serialization and deserialization process. Okay, so what this interface do? This interface have a two kind of methods. One is the write external, another is the read external. Both take, notice here, object output and object input. They are not taking object input string or object output string, because here object input stream are the part of your serializable interface. Object output stream is the class is a part of your serializable interface. For externalizable interface, they mention you can override object output stream and object input stream for the read external and write external. These are two methods. Whenever you are going to implement this externalizable interface, at that time you have to must implement this two interface. Okay, unlike the serialization, Java does not automatically serialize the fields. Here, Java is automatic serialization process is not here. Now your responsibility, you must do manually whatever you want. So here Java externalizable interface give us full control what get to serialize. And here you can to optimize the performance or custom logic or versioning, transformation, whatever the things you want, you are the full control while the deserialization process, all the serialization process. Before in the custom, we customize the default behavior of Java serialization. In the externalizable interface, we are fully controlled. We decide what want to do in the serialization and deserialization process. Okay, so let's look the example. Let's look the example. I am just write one class. So let's here we are going to implement your externalizable interface. Notice this is not a marker interface. they have defined two methods, writeExternal and readExternal. They have a two output, object output and object input. They have a different than your what till now we did here. Notice the object input stream and object output stream. Internally, this classes also is the inheritance to the object input stream. You can say object input stream is super, and after that object stream input stream. Okay, let's come here. So here you can say, okay, I'm going to implement this interface. That means we have to override these two methods. One is the writeExternal and readExternal. So let's implement these two methods here, writeExternal and readExternal right now. So here we have to override the writeExternal. So we have to override the writeExternal. Implement it, implement it. Okay, so here now notice here I'm not going to say object output stream, no, just object output. And here our responsibility to say write name, write age, write password, whatever you want. Fully control you have. There is no partially. You are not customize the default behavior. You are going to write. Okay, you have to implement it. One more method. Let's overwrite one more read external. You have to write override write external and read external. You have to read external. Okay. So here I have to, whenever you are going to implement the externalizable interface, at that time, these are the not marker interface. These are the interface. They have defined two abstract method, write external and read external. That means we have to override write external and read external. And here we have to fully control what the things you want to serialize, and here fully control what the things you want to override. Notice here, this is the password is the transit variable. Even I can serialize and even I can deserialize because this is my way to serialize. I'm not going to follow the default behavior, right? So let's test. Comment out. And what the three error cases? Simple. Okay, something wrong. Okay. So here we have a student class. They have a name, age, and even transit. Even this is the my external element. I can do it. Even I can password also serialize and deserialize. Even this is a transient because we are using the external. We have full control. So let's write the serializable code. I have written here the serializable code. So we create one student with the password secret123 and say, hey, object output system, write object. Notice still here I am doing this serialization. Notice here again I am doing to, we have a Java object. You want to serialize, that means you are again going to object output stream the write object method. But this student class is implemented serializable interface. A serializable interface internally implemented serializable interface, right? So due to that, this object output stream, no, hey, no understand this is a serializable. But here you say already overwritten write external and read internal. So internally, they are going to call your method. Here write object method indirectly they are going to the call your write external method for the serialization. So let's check. Notice they are called student write serialization. Okay? This is the methods here we call. This is the method here we call. Right? And let's deserialize them. Uh, Let's deserialize them. So while deserialization, again I'm going to say, hey, this is my serialized file. I'm going to say object input stream deserialization class and say read object. So read object, they know that this is the file already written. This is file already written here, though your student. Student. This file already written something. Notice something written here and here. So I am going to deserialize. So while deserialization, they are going to write my use the read external, and manually we have to read name, age, password, and initialize our object. So if you read here, so notice I am even notice here one thing. Be aware whenever you are going to do externalizable interface for those scenario, public default argument constructor must be. Internally, they are going to the call your writeObject method, but where the object, they are going to create the object and then set all these values. So due to that, notice here, they are called or no are constructor, then they call the externalize method, and then read external, they read all the value and initialize your object. And then you can retrieve, get your student initialize object. So here you have a full control, whatever you want. So whenever you are going to implement externalizable interface, you have to must write the default argument constructor, and you have to also override these two methods. Write external method, you have to going to write every object whatever you want, and you want to read, override the read external method. Here in the deserialization, they are going to the call. So these are the way you can do serialization. So these are the two interface: super interface, sub interface. So what do you think here? Like we have just I'm giving us some brief summary about again, right? The here control part in the serializable interface. Automatically everything happened. They are decided that all the non-static and non-transient variable going to part, but in the externalizable interface you decide yourself what the field you want. Here transient fed by default automatically skipped. Here can be handled, or you want to skip, you want whatever. Constructor, in the case of your serializable interface, no required kind of any kind of constructor, but in the case of externalizable, you must declare public no argument constructor. And performance wise, this is less efficient because they are going to automatically write every non-static and non-transient field. Let us example, you have a class that's thousand hundred of it, and you want to serialize. They almost going to serialize all 100 fields by default. But even no. While the serialization, I only interested this three field kind to go into serialize, rest that not required. So in those scenario, this is very more efficient in performance. So that's depend upon serialization and deserialization, your class structure. If your class have a 100 field and every 100 field you don't want to serialize, better you can go with the externalizable interface. Here you have full control. Let's say you want only three field, you three field serialize and deserialize three one. Okay, so this is just a summary between the your serializable interface and externalizable interface. But majorly scenario, this work fine. This is a specific say case situation where you want some more specific kind of optimization or efficiency you want. That time you can go. Okay, that's the point I had. So let's just summarize what till now we discussed. So we discussed about the Java object license, allow Java object to convert it into the byte stream and again later reconstruct it. That means we have a Java object converted to the serializable byte stream, and again reconstructed in a Java if you want. And the this is the very important essentials whenever you want to store object state persistent, or you want to communication between the services, microservices, web services, not maybe RMI call, socket call. This is the very essential. And for those objects which you want to be serialized, that must be implement maybe serializable interface or maybe externalizable interface. Notice serializable interface is a marker interface. There is a no abstract method, but in the case of externalizable, this is not marker interface. You have to override two methods, writeExternal and readExternal, to be serialized. Okay. One more things for the Java serialization, these are two very basic class, ObjectOutputStream, writeObject for the serialization purpose, and ObjectInputStream, readObject for the deserialization. So whenever you want to serialize, you have to use the ObjectOutputStream. Whenever you want to deserialize, you have to use the ObjectInputStream. Writing means serialization, reading means deserialization. Okay. And also we discuss by default behavior of serialization is all non-static non-transient fields are the part of your serialization process. This is the default behavior. You want to change, you want to customize, and if sometime you want to override some field, serializable field one, and good part you use the some documentation like at the rate serial. So like, what do you mean? Whenever I say here mention like at the rate like here see, this mention that someone reading this code and not say, hey, this is the variable declare for the serialization purpose. This is not the actual code purpose. So good option you can. This is the method used for the serialization and deserialization. This is the method used for the something. So documentation help us to code readability in the long terms. Okay, and one of the major challenges you think whenever the your Java object here in one JVM and another JVM, the same object you are going to create. So what happened is the structure, something variable change or modified. Here the two variable, three variable. So this is known as a Java class uncompatible issue. So for those compatibility, please ensure that by default the Java selection process try to automatically support, but sometime incompatible changes happen, then you can get the exception like illegal class exception, invalid class exception, because the fields are changed, maybe some data type change, something. So if something changed, that means your deserialization process is going to the break. Serializations had something and deserialization, your class structure was changed, that time it will break the deserialization process. So to avoid such a situation, generally developer we recommend, hey, please mention when the serialize version UID to ensure that if this field available while the serialization process, our JVM check already mentioned they are skip and avoid unexpected conflict or the kind of exceptions while the deserialization process. So please ensure that whenever you are going to make any class as a serializable, you also give the some unique serial version ID, so that while the deserialization process compatibility check, JVM can avoid such kind of a failure. And last more points in the Java. Till now we have only one object. What happened? One class have a hierarchical interface. Means Java support inheritance. What happened? This class is going to serialize, implement serializable interface, but they are not implemented. Then what happened? So in those scenario, for thumb rule, if your superclass implements serializable interface, then all its subclass are automatically serialized. That means if your top level class implement serializable. This is automatically part of serialization. This is automatically part of serialization. Means ki every hierarchy automatically become a serializable object. But this is not always the case. Second scenario might be this is the hierarchy. This is the hierarchy. This is the hierarchy. What happened? They are not implemented serializable. They are not implemented, but let's keep example. They are implemented the serializable interface. So while you are going to serialize this object, they are inherited field. They are inherited field. What happened those fields? So here rule for the sub case serializable interface sub superclass does not. That means subclass implements serializable here in the case, but superclass does not. So in this case, what happened? Non-serializable superclass fields are not serialized. So these are the non-serializable field, non-serializable. They are even inherited here, but they are not going to the part of serializable. That means these fields are not serialized. But whenever deserialization process happen, because whenever this class going to that time, this default constructor of these two class are going to invoked. So during the deserialization process, non-serializable superclass constructor to be called to initialize the field, because in the serialized object, let's see, this is the serialized object A and B, C are non-serialized from superclass. This value must be initialized from its superclass constructor. So we ensure Java supports serialization. If the superclass is serialized, all the subclass is automatically part of serialization. But the subclass is serialized, superclass is not serialized. So the only the subclass fields are going to serialize, superclass fields are not going to serialize. Non-serializable superclass fields are not serialized. While deserializations, the superclass constructor invoked to initialize the default value of those fields. So these are some common points which I have today. And if you want to read more detail about this Java object serializations, I'll try to cover the basics. What are the minimum things? But you want to more details, just go and read out this Java object is serialization is specification. Everything, whatever today I talk, everything mentioned in this document. I'm not talking anything by my yourself, yeah, by myself. Whatever I read this, whatever I can visualize, I can try to write example codes so that you can understand. But if you are really want to understand the deep about the object Java object serialization, you have must go and read this Java object serialization specification. This is the provided by the Java or Oracle community. So please read everything. Whatever we have read, just go here, system architecture and everything. Read whatever we discuss, everything, all the methods, all the files, whatever I'm explaining, everything's here mentioned in the detail. Nothing, anything which you cannot find here. Everything's, every method, even the more details you can find here. The good part, whatever we today learn about the Java object specification, everything you can find from this official Java documentation. Okay, don't go anywhere, just go to this official Oracle websites and read out the complete details. But if you go to this uh, example which I shared, many things you are getting very clear. I'll try to make a more simplified version of this Java object serialization. This is the beginning. You do some code practice and try to object serialization and deserialization process, and that's make you can say be confidence to the concept wise right now. So the only basic concept we today cover, and you want to more detail, you can go with the Java object specifications. But whenever you have a Java object, you can using the deserialization process convert to the byte stream, and again deserialization process you can convert again back to the Java code. So for serialization object output stream for deserialization object input stream API help us. So hope this information give you the very basics about the Java object serializations. For more detail, you check out the Java object specification from the official Java website. Hope this information is helpful for you. Thank you.